Hey guys, so continuing talking about sensation and perception. Um, we looked at vision last module, and now we're going to look at hearing. All right. So the process of hearing is called audition, and just like when we're talking about sight, when we had waves of light, we're still talking about waves, but with hearing, we're talking about sound waves. Okay, and just as with light, um, the wavelength and the amplitude affected the hue, affected the brightness of of the um, of the what we're looking at, the color we're looking at. Same thing happens with sound waves. Okay, so the pitch that we hear is determined by the wavelength, so from the crest of one wave to the other, and then the amplitude is the loudness of that particular sound, and just as purity impacted um, the saturation for vision, purity affects the timbre for sound. Okay, um, the loudness of sound is measured in decibels, the intensity of the sound, and this is kind of just some general information. You want to make sure you're keeping your sound below 85 decibels for you people like to put in your headphones right into your ears and blast your music as loud as possible. You are putting yourself at really serious potential hearing damage that might not manifest itself for a little while, but it could come back to bite you from years down the road. So make sure you're listening to your music uh, or your movies or YouTube videos or whatever at a reasonable sound. So the sensation, first of all, okay. How do we take in those sound waves? How does the transduction happen to transfer them into something that our brain can actually understand and interpret? So obviously the organ involved is the ear. Okay, so sound comes through your outer ear here and then touches up against your eardrum. That then sends vibrations down through the middle ear, okay, through your hammer, anvil, and stirrup, your middle ear bones here. All right, and then you have your cochlea, which is the main kind of active component in your hearing. All right, so there's a fluid in here. It is uh, excited by the vibrations traveling through your bones of your inner ear. That then is picked up by the nerves, okay, of your auditory nerve here, the nerve fibers, I should say. And then that auditory nerve goes here to your temporal lobe of your brain, where it then is interpreted as sound. All right, so make sure you understand this structure. Um, and these semicircular canals, even though they're in the ear, aren't actually part of the hearing process. This is actually for balance and your orientation for where you are. That we'll look at in our next module. Okay, so eardrum through the bones, the cochlea, and then up to the brain. And then here we have again outer ear, your canal, um, middle ear, the middle ear bones, and then the inner ear where the actual transduction happens. So, how exactly do we hear sound, and how do we differentiate pretty remarkably all the different pitches and sounds that we hear? Um, just as with vision, there's a couple competing theories. All right, so the first is the place theory, which is kind of the first. And essentially, that idea is depending on the pitch of the frequency of the sound wave as it moves through, it goes through your cochlea and will excite the membrane at different places. All right, so certain sound waves will uh, excite your cochlea like right up front, and those nerve fibers will pick it up, and then certain ones will excite their cochlea further back here, and then those fibers will pick it up. So depending on where or the wavelength of the sound wave moving through will excite your cochlea in different areas, and that's how your brain differentiates different pitches from one another. Then we got the frequency theory, which states that different frequencies flow through your actual auditory nerves at a faster or slower rate. Okay, so matching the frequency to the pitch, it will move through. Some will move through faster, some will move through slower, and then your brain will be able to interpret that as different pitches in the sound. Okay, so we got our place theory, our frequency theory, the different ideas of how exactly our brain interprets all the different types of sound that we're almost constantly bombarded with. Um, so those are the two theories to make sure you're aware of. Okay, now we got hearing loss, which is an unfortunate reality for most people. As you get older, you're able to pick up fewer and fewer, so you're unable to pick up higher frequency sound waves. You're still pretty good on the lower frequencies, but the really higher frequencies, it's really tough to pick them up as you get older. So you got those frequency players. If you're some person in class, you know, set them off, and maybe the teacher's like totally oblivious to it, but everyone else in the class is like, what is that or whatever. It's because people who are older, they just can't pick up that high frequency. Okay, so a couple of different types of hearing loss. Conduction hearing loss is the actual kind of mechanics of the inner ear, uh, that the system that finally brings it to the cochlea. There's some sort of damage there. Okay, so the process of getting everything to the cochlea so the auditory nerve can pick it up, that is damaged. Versus the nerve hearing loss, where your brain, sorry, your ear, the outer ear, the inner ear, all that kind of stuff, probably functioning just fine, but the auditory nerve itself, and the receptors as it connects to the cochlea are damaged. Okay, so everything's kind of working fine, working fine, working fine, and then it gets to that really end part of where it actually is transferred information to the brain, and that's where the problem is. So conduction, kind of the process leading up to going into the brain, there's a problem there. Versus nerve hearing loss, everything's working fine, and then when it gets to the part of actually bringing that information to the brain to be processed, now there's the problem there. Another cool aspect of sound is our ability to pick up where it is. So you can like hear, someone snapping back here, and you pretty much instantaneously, for most of the time, can be like, what's going on? Like, someone calls your name, hey, they're behind me, what's going on? Okay, so how do we do that? How are we able to locate where a sound is coming from? What's its origin? So we have our person here, we got our bell. They ring the bell. As they do that, it's sending out sound waves through the air. Okay, and as those sound waves get further and further and further away from its original source, those sound waves become much less intense. All right, so essentially one ear, kind of depending. I mean, if it is to your right side like this, what's going to happen is the right ear is going to pick up that sound first before the left ear picks it up, and it's also going to be more intense. Okay, so if you like, hey, it's clearly louder over here, it picks it up first, then this ear picks it up, and it's not quite as intense. Your brain does a really amazing job. It happens almost instantaneously of being able to know, okay, the sound's over here. Okay, so what the process is of audition, make sure you know the mechanics of the ear, make sure you know the different theories of why we can hear different frequencies as well as we can, and then how we can be able to understand where exactly a sound is coming from. And let me know if you guys got any questions.